Okay, question 7. Proof by induction. Prove by induction that 2 to the n plus 1 plus 5 times 9 to the n is divisible by 7 for all integers greater than or equal to 1. So we start by proving this for n equals 1. So if n equals 1, 2 to the n plus 1, 2 to the 1 plus 1, sorry, plus 5 times 9 to the 1 is 2 plus 5 times 9, 2 squared plus 5 times 9, so that is 4 plus 45, which is 49, which equals 7 times 7, therefore divisible by 7. Okay, now we state our assumption, so we're going to assume that if n equals k, then 2 to the k plus 1 plus 5 times 9 to the k is divisible by 7, so is written as 7a for some constant a, where a is an integer. Okay, so that's our way of assuming that it's always going to be divisible by 7. Now we need to consider if n equals k plus 1. So what do we end up with n being k plus 1? Well, 2 to the k plus 1 plus 5 times 9 to the k plus 1. So that's 2 to the k plus 2 plus 5 times 9 to the k plus 1. Now a standard thing to do with these is to consider what would be going on if we started to look at a subtraction, look at the difference between two terms. So I am going to consider uk plus 1 take away uk. So uk plus 1 is 2 times 2 to the k plus 1 plus 9 times 5 times 9 to the k. I've just rewritten that line, splitting up those indices. Take away uk, and uk is what's uk? 2 to the k plus 1 plus 5 times 9 to the k. I'll put that in brackets as we start to consider what's going on with that. Right, we've got some common factors here, haven't we? So we've got 2 to the k plus 1 times 2 minus 1, because there's 2 of them there, take away 1 of them there. We've also got 5 times 9 to the k, and we've got times 9 take away 4. 9 take away, 9 take away, I don't know where the 4 came from, 9 take away 1. There we are, so we've got that expression coming out of this. So what is that we've got? We've got 2 to the k plus 1 plus 8 times 5 times 9 to the k, but actually that is 2 to the k plus 1 plus 5 times 9 to the k plus another 7 times 5 times 9 to the k. That's splitting up the 8 into 1 and 7. And actually, that expression there is UK, isn't it? That's the case term. We've already assumed that. Actually, at this point, we kind of realised that we could have done this without doing a subtraction. But what we've got is u to the k plus 1 minus uk is equal to, that is uk, isn't it? That is the kth term, plus 7 times something. 7 times 5 times 9 to the k. So uk plus 1 is 2 uk plus 7 times 5 times 9 to the k, which is 2 lots of 7a, or 7 lots of 2a, plus 7 lots of 5 times 9 to the k, therefore divisible by 7. We've just clearly shown it's divisible by 7, and there we go. Therefore, assuming true for n equals k, it is also true for n equals k plus 1. As it's true for n equals 1, by induction, two to the k n plus 1 plus 5 times 9 to the n is divisible by 7 for all integer n greater than or equal to 1. And there we go, and that's maths.